All right, last class we went ahead and solved absolute value functions. This time we're going to go ahead and solve absolute value inequalities. So a lot of the same stuff that we did in solving equations is going to be used in solving the inequalities. We're going to start by showing you this graphically, so you can start making connections on why that inequality works the way it does. So we've got x plus 2 in absolute values here is less than or equal to 5. Now, if you remember from graphing, if we were to graph this absolute value here, x plus 2, that was an absolute value parent function that went to the left 2. So we went ahead and graphed that right here. Our vertex went to the left 2. Every single point went to the left 2. So we've got our absolute value. And both of these are the same. So we have graphed that absolute value. The next thing we graphed was the 5. And so y equals 5 is a horizontal line at 5. So we made a horizontal line at 5. And so now, when we compare these now, this has a less than or equal to 5. So we want to know where this absolute value is less than 5. And so we see the shading here. This is less than 5 right here. 5 is right here. The smaller ones are this portion here. So this would be an example of the B graph. Now, when we look at the values that fall in this shaded area, it would be from here to here. So in between -7 and 3 is where our solutions would be. So when it's graphed in this format, here's -7, here's 3, and here is in between. So C would be the other example of this graph of all of our solutions. When we look at this one, it says x plus 2 in the absolute value is greater than or equal to 5. And so this is where they're equal to 5, and then everything greater than 5 would be up. So we've shaded this area here. So this is an example of the A graph. Now, if we look at our solutions, the part that's in our solutions is this part and this part right here. And so in this case, it is split. We've got two sets of solutions. And so the other example of the graph would be D. Let's think about that a little bit further. If we think about what lands what lands inside of this? Well, we know that everything that comes out of the absolute value is non-negative. So if we had a -6, for example, here, it would come out as a +6, which is bigger than 5. So all of the values less than -5 are going to give me a solution, and then all of the values bigger than 5. So that splits into being those smaller values and then the bigger values. That's why we get those two pieces right there. Where the other ones, in this case, if we went to -6 here, it would come out as a +6, which is not less than or equal to 5. And so we have to block those out. So all of the points are in between. Anything that's really small is going to be too big once it comes out of the absolute value, and anything bigger is also going to be bigger than 5. So that brings us to our setup here. This setup is crucial. You've got to know this right here. And it looks like a lot to go through and know, but really these two are the same and these two are the same. The difference between these two is that this has an equal sign and this one does not, but they're both the less than. And so we just discussed when it was the less than, it is the values in between. So we set up this compound inequality here from negative to positive of whatever's on the other side of my absolute value. Now we do that once the absolute value is isolated. So the first step would definitely be to isolate. On the bottom ones here, they're the ones that are greater than or equal to. In this case, we said we have the two pieces, all of the values that are smaller than that number. And so we set up the absolute value part less than the negative. And then all of the values that are bigger than that one. So we're going to take everything inside the absolute value and set it up to what is bigger than that value. Sounds confusing, but once we get to doing the examples, I think it'll make a little bit more sense. So we've written out the two examples there so you see them. Again, if it's greater than, it's going into the two separate ones. If it is the less than, it's going to be this compound one where x is in the middle. So for example here, the absolute value of 2x minus 5 is less than or equal to 7. We are on the less than or equal to. So that's this one. I'm going to set it up as 1. Just like with the equations, we had to think about the negative and positive. That's what we're doing here. So we're going to set up -7 and then the less than or equal to sign. So you're keeping that same sign. What's inside of the absolute value and then less than or equal to 7. Now it's solving like normal. So I'm going to add the 5 to get it to the other side. And whatever you do to one side, you have to do to the other, which this one has 2 sides. So we're going to have to do it to both sides. And so my 2x stays in the middle here. -7 plus 5 gives me a -2. 7 plus 5 gives me 12. And then I have to get rid of the 2. These are being multiplied, so we divide by 2. And so -2 divided by 2 is -1. My x is in the middle, and 12 divided by 2 is 6. So our solutions are all of the values between -1 and 6. If I'm graphing that on a number line, I'm going to go to -1, and it is going to be a closed circle. Because it's equal to, we want -1 as one of our solutions. So that is -1. Then 6 is our other solution, so I want that one as well. That's when it's equal to. And then we want all the values between that, so these are all of our solutions right here. All right, now we're going to try the other setup. So in this one, we've got the absolute value, and it is greater than 7. So we know that every value that comes out of here, that's -7 or smaller, is going to come out as a positive that's bigger than 7. And we know every positive value bigger than 7 is also going to be bigger than 7. So we want to set that up. So -3x plus 2 has to be less than -7. We want all the smaller values than -7 because, for example, -8 comes out as a positive 8, which will make that a true statement. So we want all of those values that are smaller than -7. Then we want all the ones that are bigger than 7. So we're going to do -3x plus 2 is greater than 7. Now we start to solve. So we subtract this 2 to get it to the other side. We get -3x is less than -9. And then these two are being multiplied, so we are going to divide by -3. So go back and think about when you first learned about inequalities. You should have learned that anytime that you divide or multiply by a negative, you have to flip the sign. So x is greater than 3. Now we're going to do the same thing over here. We subtract the 2 to get it to the other side. And so that's going to give me -3x is greater than 5. And then we divide by -3. And so x, whoops. Make sure you call me on that. You got to flip the sign. Anytime you divide or multiply by a negative, you got to flip that sign. So that needs to flip. And we get -5/3. All right, so at 3, we have an open circle in this case because there's no equal sign. So this is when x is 3, and that is not a solution. So we're going to have an open symbol there. And we want all the values that are bigger than 3. X is greater than 3. Well, x gets bigger as it goes to the right, so we're talking about all of these values here. Then x is less than -5/3. 3 goes into 5 one time. So we would go 1 and then a little bit more for that 2/3. And so there is my other open circle. And we want the value smaller than that, so we're going to go to the left on that. And so there is our solutions in the split ones. So those are the 2 setups there. All right. Try a couple of more examples here with a little more steps. So in this case, before we can do the setup, I cannot take anything out of this absolute value until I do the setup. And I can't do the setup until it is isolated. So I need to bring this over first. So my first step is to subtract 2 to get it to the other side. And so we get the absolute value of -5x plus 8 is less than 23. Now we're ready to do the setup. That's the only time you can get something out of that absolute values. This is less than, so we're going to do -23 is less than -5x plus 8, which is less than 23. It was less than here, so we do the one with the between. All right, so now we're going to subtract this 8 to get it to the other side. And so that leaves me with negative 5x in the middle. When I subtract 8 from this side, I get 15. When I subtract 8 from this side, I get negative 31. Now it's time to divide since these two are being multiplied. Remember what happens when you divide by a negative? We're dividing by a negative right now. So those signs have to flip. And so that gives us negative 3 over here and 31/5. Now that's a true statement the way it's written, but we never leave it in that format. It should read from left to right, so we should have our smallest number on the left and our biggest number on the right. So we rewrite it to make sure that it looks correct here. And so we're saying all of the values between negative 3 and 31/5. So at negative 3, I'm going to have an open circle because there's no equal sign there. 5 goes into 31 6 times, so that's going to be an open circle there. And then we shade all of the values in between. All right, one more example to do here together. So we're going to add the 5, and so we've got the absolute value of 4x minus 3 is greater than or equal to 15. We added that 5 to get it to the other side. This absolute value is on the open side. It is greater here. So this is the one that needs the double setup. So we do 4x minus 3 is less than or equal to the negative, so negative 15. And then 4x minus 3 is greater than or equal to 15. We start solving. So we're going to add this 3 to get it to the other side. So we get 4x is less than or equal to negative 12. And then we divide by 4. So x is less than or equal to negative 3. All right, for this one, we add the 3. And then we divide by 4. Whoops, I did not add 3 there. That would be 18. We divide by 4, and so we're going to get x is greater than or equal to 18 over 4. That's a perfectly good fraction, but if you want to reduce it, that's going to be x is greater than or equal to 9/2. So at negative 3, we're going to have our closed-in circle, because this has an equal sign, so we want negative 3 to be part of our solutions. We also want 9/2 to be part of our solution, so that's going to be a closed circle as well. And then we need the values that are less than negative 3, so that's going to be these, and greater than negative 3, which is those. All right, we have 2 here for you to try, so go ahead and pause the video, give them a try, and then come back and check your work to make sure you know how to do it. All right, check your work. Make sure you've done it correctly. Make sure that you flip the signs here when you divided by a negative 8. And so those signs flipped. It is shaded on both sides on the outside part. All right, now we're going to talk about a word problem. And so it tells us the official rules of baseball state that all baseballs used during professional games must be within a specified range of weights. The baseball manufacturer sets the target weight of the balls at 145.045 grams on its machine. The specified weight allows for a difference of 3.295 grams, which is known as the allowable variance. This means the weight can be 3.295 grams greater than the 145.045 or less than the target weight of 145.045. All right, so we would set this up as an absolute value. And so it tells us the actual amount minus the target amount is going to be less than or equal to the variance. So let's go back and think about the first day when I told you guys that absolute value is the distance. And so when it's just the absolute value of something, it's from the distance of 0. When we subtract the target amount here, we're going to get the distance from that target amount, the 145.045. So we can check to see if it is below by those two things. So when we set this up, we would have our absolute value. X is going to be the weight that they're checking. minus our target weight of 145.045, and that has to be less than or equal to 3.295. So when we do this subtraction here and it comes out of the absolute value, we're going to know that distance from 145.045. And we want it to be less than or equal to 3.295 so that it is in regulation. And so to solve this here, we would then, this is less than or equal to, so we set up our 2 of 3.295 is less than or equal to x minus 145.045 is less than or equal to 3.295. And so we are going to add the 145.045 to each side. All right, so this tells us that the baseballs have to be between 141.75 and 148.34. If we get a ball within that, so 142, yes, that would be within range because that falls between this. Now, if we got something like 141, that would not be in range because that is smaller than 141.75. Or if we got 149, that's greater than this, so that would not be in range either, and we would not be allowed to play with that. That's one of the biggest examples that we see of the absolute value. There you see an applications problem. All right, now you know how to solve inequalities.